Hello, Geometry! Thank you for tuning in. Thank you for watching. I hope you're enjoying whatever day you are having. I hope it's a good one. We're doing a lesson that I really enjoy. We are discussing volume. I really enjoy volume. Um, yeah. So let's jump into it. So we're looking at these three-dimensional figures, these polyhedrons, and we're going to be finding the volume of all of them. And the generic volume formula is volume equals area of the base times the height of the prism. Volume is equal to area of the base times the height of the prism. Okay? So this is why I made such a big deal about base, because you need to find the area of the base. So what is the shape of the base for question A? This is a rectangular base, okay? The base of this prism is a rectangle. We have that rectangle on top, and we have the same rectangle, or I said top when I meant bottom. We have that rectangle on bottom and the same rectangle on top. And then we connected the two together. That's how prisms are made. You connect two bases together. So what is the area of this red rectangle? We want to find the area of the base. Well, the area of the base, length times width, right? Because it's a rectangle. So 5 times 6, the area of the base is 30. And what is the height of the prism? It's very clearly labeled for us, height being the distance between the bases. This is the distance between the bases, okay? Height isn't always measured vertically. Keep that in mind. When we say the word height here, it isn't always measured vertically. And you'll see why in a moment. So we found the area of the base, and we multiply that by the height of the prism, and we get 240 feet squared. Simple enough, eh? Let's do it again. We look at question B, and we say, what is the base of this prism? Well, is the base this rectangle? Is this rectangle connected to another rectangle? No, it is not. The base of this prism is not a rectangle. The base of this prism is a triangle. This is a triangular prism. We have a triangle in front, a triangle in the back, and we connect the two together to create a triangular prism. So what is the area of the base? Meaning, what is the area of this triangle? Well, 1/2 base times height. Don't confuse base and height here. I'm talking specifically about the triangle. So we have 1/2 times 12 times 16, because that's the dimensions of the triangle. And when you plug that into a calculator real quick, half of 12 is 6, and 6 times 16 is 96. So the area of the triangle is 96. And what is the height of the prism? The height is not this vertical distance of 16. That is not the height of the prism. The height of the prism is the distance between the bases. These bases are separated by a distance of 10 centimeters, okay? So we do 96 times 10, which gives me 960 centimeters squared. You see that? When we say the word height, we're not talking vertical. We're talking about how far away the bases are, because you could put this triangular prism upright, right? It's sitting on a triangle and the triangle's on top, and then the 10 becomes the height, right? It's all a matter of perspective. Equilateral triangular prism. Let's do it again. It tells us the name. Obviously, this is the base. This is the base of the prism. So we have two triangular bases. So what is the area of this triangular base? We find the area of the triangular base, and the two bases are connected, of course. So the base, the area of the base is, again, 1/2 base times height for a triangle. So that's going to be 1/2 8 times 4 root 3. Don't let the 4, 3 mess with you. Just leave it alone for now, okay? So half of 8 is 4. 4 times 4 is 16. So 16 root 3. Don't plug that into a calculator. Why do you want to write a decimal down? Just leave it as 16 root 3, okay? 16 times root 3 is the area of the base, and then we multiply that by the height of the prism. And the height is how far apart the bases are. They are separated by a distance of 16, or 12, sorry. So we multiply by 12. 12 times 16, I can't do that in my head very easily, so I'll check. 192 root 3 centimeters squared. And now lastly, when I write my answer on the blank here, I'll go ahead and plug it into a calculator. We have 192 times the square root of 3, and I get 332.6 centimeters squared. Am I making sense here? I hope so. You identify the base, you find the area of said base, and then you multiply by the height of the prism. That is it. This one's a little cute here. Let's do this one. Find the height of the triangular base of a right prism if the volume of the prism is 30 centimeters cubed. The height of the prism is 3 centimeters and the base of the triangle is 14 centimeters. So let's draw this right triangular prism, okay? It looks like this. That's terrible. It looks like this, okay? And let's copy this so that way it's exactly the same size. And then let's connect the two together with beautifully straight lines like so. Gorgeous, right? Okay. So the volume of this prism is 30 centimeters cubed. And the height of the prism is 3 centimeters. So the distance between the bases, the height of the prism, the distance between the bases is 3 centimeters, and the base of the triangle is 14. This is clearly not drawn to scale. Find the height of this triangle. So we're working backwards. We already know the volume, and we're trying to work backwards. So volume is equal to area of the base times the height of the prism. So 30 is equal to, do we know the area of the base? Think about that for a second. Do we know the area of this base? No. We know the length of this triangle, but we don't know the height. So you can't find area if you don't have both dimensions. So we don't know the area of the base. But we do know the height of the prism. That's 3. So we can work backwards a little bit. Let's divide away the 3. So what you're telling me is that the area of the base is 10. If the height of the prism is 3, then we're kind of forced to say that the area of the base is 10, because 10 times 3 gives me the 30. So now we need to work backwards a little bit more. The area of the base is 1/2 base times height. So 10 equals 1/2 14 times the h that we're missing. Half of 14 is 7. Divide the 7 away. So my height is whatever that is, 10/7 centimeters. I'm not going to re-explain that too much because you can rewind the video, but take a step back if you got lost at any point. I'm just working myself backwards. I'm filling in the info that I know and solving for the info that I don't know. Filling in the info that I know and solving for the info that I don't know, okay? Let's do it a couple more times with cylinders here. When we do area of the base, what is the area of our base now? It is a circle, of course. So what is the area of these circular bases? I love filling it in and shading it. It makes the pictures look pretty. We can clearly see these circular bases, and they're being connected by our trusty straight lines here. So the area of the base times the height gives me the volume. Well, our base is pi r squared, of course. So that comes out to be 36 pi. 6 squared is 36. And then we come in here and multiply by the height of the prism. 36 times 18, I don't know what that is. 648 pi. And then lastly, I'll go ahead and plug pi into my calculator. So 648 times pi, and I get 2035.8 inches squared. So we learned all about circles in our last unit. We found area of circles several times over, right? So we found the area of the circular base and multiplied it by the height of the prism. How about I finally ask you your first question here. Find me the volume in decimal form here of the cylinder. You must find the area of the circular base and multiply by the height of the prism. Some decimal answers pop up on screen. So you paused, you solved the problem, and you answered the question. What did you end up with? The area of the base, pi r squared. You might have been tempted to square 16, but you were wrong if you did that. Half the diameter gives me the radius. So the radius is 8. So the area of the base is 64 pi. The area of the base is 64 pi. And then you multiply by the height of the prism. And 64 times 21 is 1,344 pi. And when you plug that in, you get a nice large decimal answer of 4,222.3 feet squared. So if you got that answer, great job. Let's do some more solving here, except with pyramids and cones. We're at 12:15. We got this. We got this. So, volume of pyramids and cones. It's the exact same formula, except we only want a third. We're going to divide our answer by 3. Feel familiar? Right? Area of rectangles is length times width. Area of a triangle is 1/2 length times width, right? Base and height. It's kind of the same idea. Like, oh, a prism is like base times height, but then pyramid is 1/3 base times height. Sort of a similar idea. I just want you to, not forget about the 1/3, okay? So, find the area of the base. This is a square. It's 10 by 10 by 10 by 10. So the area of the base is 100. And then you multiply by the height of the pyramid, which is 12. And you get 1,200, but you divide it by 3. So we get 400 yards cubed. 400 yards cubed. How about I have you jump right into one just for yourself here. Jump straight into one here, right? I mean, it's the same idea, same exact idea, except we're dividing by 3 at the end. So same exact idea here for B. Another one with a circle. Put those calculator skills to the test here. Another one with a circle. Find the area of that circle. Multiply by the height. Don't forget the 1/3. Some answers pop up on screen. Area of the base is pi r squared. So we've got 9 pi, because we squared the 3. The height is 8. So let's just go ahead and multiply that by that 8. 9 times 8 is 72 pi. And we divide by 3. 72 divided by 3 is 24 pi. Go ahead and plug that into a calculator. 24 times pi is 75.4 millimeters cubed. Have I been writing squared? I did write squared a couple of times. Volume is cubed. Silly goose. Volume is cubed. Forgive me. Forgive me. Okay. Let's just move on. Let's just move on, right? We keep doing the same thing, right? We keep doing the same thing. Do we need to do it again and again and again? Probably not. We can do some in the Socrative. Find the right. We're doing the same thing. Let's look at one more idea here, and that is Cavalieri's principle. I don't really know who Cavalieri is, but I guess he came up with it. If two solids have the same height and the same cross-sectional area at every level, then they have the same volume. Okay, what does that mean? Well, that means that this parallelogram-ish looking thing, right, has the same volume as this perfect rectangular prism with the same dimensions. That's what that means. Just because we sort of shoved it over doesn't change the story. Okay? This box, which has the same dimensions that stands straight up, will have the exact same volume as this box with the exact same dimensions. Just because it's tilted doesn't change the story. Okay? And there's these pictures of these pennies here. Are those pennies? Or those quarters? I can't even tell what those are. I'm not going to lie. What are those? Is that a 2-cent coin? What the heck? Okay. Anyways, it's the same. Let's say they're pennies, okay? Just for the sake of my mind being at rest here. Just because when you take 8 pennies, right, and then you shove them around, have those 8 pennies changed just because they're not stacked beautifully? No, it's still the same amount of penny. When you put them on the scale, whether they're stacked beautifully or whether you just toss them in a bin, they're still going to weigh the same amount. They're still taking up the same amount of space. Everything about the pennies is the same. Just because it's not stacked beautifully doesn't mean that the composition has changed. And that's what we're trying to say here. Just because this box has been shoved at an angle doesn't mean you've really changed the box. That's all we're trying to say. Okay? So we don't need to do anything different. Just because it looks a little askew doesn't mean we have to totally change how we do things. We still find the area of the base and multiply by the height. And when it comes to stuff like cones and pyramids, like this guy, you do 1/3, right? So how about I put your skills to the test one more time. We're under 20 minutes. Last question here. Find the area of this oblique, as we're calling it here, oblique polyhedron. Area of the base times height. Do you need to do 1/3 here at all? No, because it's not a cone and it's not a pyramid. So base times height. Some answers pop up on screen. So how'd you do? The area of the base is 12 by 6, aka 72, and you multiplied by the height, which is 8. 72 times 8. Hopefully you got an answer of 576 inches cubed, and we call it a day. Under 20 minutes. Thank you for your time. If you're watching this on the weekend, I hope you enjoy the rest of your weekend. I'll see you soon, and yeah. Ta-ta for now.